Welcome back, this is Earl Samm. Today we're going to be solving this calculus problem that says if y equals to x raised to the power x, watch, not x raised to the power a constant like 2 or 3, x raised to the power x. So y is x raised to the power x, find dy dx. So we have to find the derivative of x raised to the power x. Okay, if you're excited to solve with me, let's go. Our solution. So the question says y equals to x raised to the power x. Okay, so now this is a function on its own, not a constant. So what do? You know, if you had y equals to, let's say, x raised to the power n, where n is a constant, you will say your dy dx is n multiplied by x raised to the power n minus 1, right? But now this will not apply here. So let's apply some mathematical trick. Now we can introduce logarithms at this point so that we can bring that number, that x, down. So if we do that, let's introduce logarithm to both sides, natural logarithm. So ln y will be equal to ln x raised to the power x. So we just introduce ln to both sides, which is natural logarithms. So from here, ln y will be equal to x ln x. Remember the law of logarithm that says if you have log a raised to the power n, this is n log a. That this n can be brought down this way. So this is a law of logarithm that is generally known. So this gives us x log x. Now if you look at this is a product, right, of two functions. So we can solve for dy dx. Now we can differentiate both sides. So if we differentiate ln y, remember ln x equals to 1 over x. If you remember, if you differentiate ln x, you have 1 over x. And if you integrate 1 over x, you have ln x plus c. If you remember all of this from our basic calculus class. So if we differentiate ln y, we're going to have 1 over y. Remember, we're differentiating with respect to x. So for this y, we'll have dy dx equal to, now this is a product. When you're differentiating a product, use what they call product rule. Product rule says if you have uv, when you differentiate, you have first u dv dx. That's write down the first, differentiate the second, plus v du dx. Write down the second, differentiate the first. So this is what product rule says. So u dv dx, write down the first, differentiate the second. So the first is x, multiply by differentiate the second. If you differentiate it in x, you have 1 over x, right? Plus v du dx means write down the second and then differentiate the first. So the second is ln x. Differentiate the first. If you differentiate x, you have 1. Okay, so let's make it clear. 1 over y dy dx equal to, this is x multiplied by 1, that's x over x plus ln x, because 1 multiplied by ln x is also ln x. So this will cancel, obviously. We'll have 1, 1. So what we'll have now is 1 divided by y dy dx equal to 1 plus ln x. Now remember that dy dx is our goal. We have to find the derivative of this function. So from here, we can multiply both sides by y. Since we have a 1 over y here, if we multiply this by a y, that y will cancel this y, and then we'll have our dy dx left. So we can choose to multiply both sides by y. So y multiplied by 1 over y dy dx, hope this is obvious, okay, equal to y multiplied by 1 plus ln x. Okay, so let me move up to continue. I think rubbing this now is fine. Or let me continue here. So from here, watch, this y, we cancel this y, so that we have dy dx left. So dy dx is equal to y multiplied by 1 plus ln x. Okay, so that's what we have. But remember that from the original question, our y is x raised to the power x, right? So we're justified to say that the y dx is equal to y, which is x raised to the power x, into 1 plus ln x. This is a 1 plus ln x. So, and that's our answer. Okay, so that's an interesting one. I remain Earl Samm. Kindly subscribe to this channel to keep getting interesting solutions to mathematical problems.